Hello everyone. In this lesson, I'll solve the exercises of lesson 4.2 second derivative test. But before solving the exercises, we will take some notes. Test for concavity. If f of x is twice differentiable function on the open interval I, then if f double prime of x greater than 0, then the graph of f is concave. If double prime of x, the second derivative of the function f of x less than 0, then the graph of f is convex. The concave shape is like a cup, or take this or this shape also. The shape of convex is like a hat, or take this or this shape also. The definition of inflection point: if f double prime of x equals 0, or f double prime of x does not exist at x equals c, then c and f of c is a point of inflection of the graph of f if satisfied the condition. Change the graph of f from convex to concave, or the reverse, from concave to convex. Note, if f prime of x has a local maximum or local minimum point at x equals c, then x equals c is an inflection point for f of x. How to apply the second derivative test to find relative extremum of a function? Follow these 6 steps. Find the critical point of f of x. Find double prime of x, the second derivative. Find double prime of c, the second derivative of x at the critical point. If f double prime of c is greater than 0, then f of c is a local minimum point for f of x. If double prime of c is less than 0, negative, then f of c is a local maximum point for f of x. And if f double prime of c is 0, or f double prime of c is undefined, then the test fails. Note, f of prime is increasing if and only if f is concave. That's mean f double prime of x is greater than 0. And f prime is decreasing if and only if f is convex. That's mean f double prime is less than 0. Exercises of lesson 4.2, question number 1 to 4. Identify the open interval on which the graph of the function is concave and those on which is convex. Question number 1, the graph, as you see, it is concave from negative infinity to positive infinity, open interval, concave. The second graph, or question number 2, the function is concave from negative infinity to 1, from negative infinity to positive 1, open interval. The function is concave, and it is convex from 1 to positive infinity. The function is convex. Question number 3, the function is concave from negative infinity to negative 1, and from 1 to positive infinity. This is the interval of concave, and it is convex from negative 1 to 1. Convex. Question number 4, the function is concave from negative infinity to negative 2, and from 0 to 2, union from 0 to 2. This is the intervals of concave. And it is convex from -2 to 0, -2 to 0, union 2 to positive infinity. This is the interval of convex, where the graph of the function is convex. Question number 5 to 11, find the point of inflection of the given function. First, we find the critical point, f prime of x equal to 3x power 2 minus 12x plus 12. The second derivative is f double prime of x equal to 6x minus 12. Set it equal 0. Then find the value of x. 6x equal 12. Then x equal 12 over 6 equal 2. Let us check this point, if it is an inflection or not. Find the sign of the second derivative before and after 2. Before 2, we take 1. 6 times 1, 6 minus 12. The second derivative is negative. After 2, take 3. 6 times 3, 18 minus 12, 6. It is positive. Therefore, this is the interval of concave, and this is the interval of convex. Negative infinity to 2, it is convex interval, and 2 to positive infinity, it is concave interval. And 2, substitute 2 in the function to find y coordinate. 2 times 3, 8, minus 6 times 4, 24, plus 24 equal 8. 2, 8 is an inflection point. Question number 6. Find the first derivative of this function, f prime of x equal the first function times the derivative of the second function, 1 over 2 square root x plus 3, plus the second function square root x plus 3 times the derivative of the first function, 1. Simplify this function, x over 2 square root x plus 3 plus square root x plus 3. Find the common denominator, equal to 2 square root x plus 3, x plus 2 times x plus 3, equal to x plus 2x plus 6 over 2 square root x plus 3, equal to x plus 2x, 3x plus 6 over 2 square root x plus 3. Find the second derivative of this function. The denominator, 2 square root x plus 3, times the derivative of the numerator, 3, minus the numerator, 3x plus 6, times the derivative of the denominator, 2, 1 over 2 square root x plus 3, over denominator square, 4 times x plus 3, equal to, simplify this, 3 times 2, 6 square root x plus 3, minus, reduce 2 with 2, 3x plus 6 over square root x plus 3 over 4 times x plus 3. Find the common denominator for the two terms in the numerator, square root x plus 3 times 6 square root x plus 3, 6 times x plus 3 minus 3x minus 6 over 4 times x plus 3 equal to 6x plus 18 minus 3x minus 6 over square root x plus 3 times x plus 3 x plus 3 to the power 3 over 2 equal to 6x minus 3x, 3x, 18 minus 6, 12 over 4 times x plus 3 to the power 3 over 2. Set it equal 0. Then cross multiplication, 3x plus 12 equals 0. 3x equal negative 12. X equal negative 12 over 3 equal to negative 4. This is the critical point. X equal negative 4, not in the domain of the function, because the domain of this function is from negative 3 to infinity, and negative 4 is less than negative 3. Therefore, negative 4 is not critical point. But as you see, the second derivative undefined at negative 3. If we set 4 times x plus 3 to the power 3 over 2 equals 0, then divide both sides by 4 and take power 2 over 3 for both sides, then x equal x plus 3 equals 0 and x equal negative 3. This is also a critical point. We find the sign of the second derivative before and after negative 3. Let us find it here. This is negative 3. Before negative 3, we take negative 4, but negative 4 is not in the domain, so the function is not defined before negative 3. After negative 3, take negative 2 and find the sign of the second derivative. 3 times negative 2, negative 6 plus 12, 6 over positive value, it is positive. Then the interval of concavity is from negative 3 to positive infinity. The function is always concave and there is no inflection point. Question number 7. Find the first derivative of this function. The denominator x power 2 plus 1 times the derivative of the numerator 1 minus the numerator 1 times the derivative of the denominator 2x over denominator square. Simplify this function. X power 2 plus 1 minus 2 x power 2 over x power 2 plus 1 square equal to x power 2 minus 2x power 2, 1 minus x power 2 over x power 2 plus 1 square. Find the second derivative of this function equal to the denominator x power 2 plus 1 square times the derivative of the numerator negative 2x minus the numerator 1 minus x power 2 times the derivative of the denominator, the derivative of the bracket 2 the second derivative of this function f double prime of x equal to the denominator x power 2 plus 1 square times the derivative of the numerator negative 2x minus the numerator 1 minus x power 2 times the derivative of the denominator, the derivative of the bracket 2x power 2 plus 1 times 2x, the derivative of the term inside the bracket, over x power 2 plus 1 to the power 4. Simplify this function, x power 2. Factorize this term and this term by x power 2 plus 1. Then, from the first term, we have x power 2 plus 1 times negative 2x minus 1 minus x power 2, 2 times 2x, let us write it, 2 times 2x, 4x, 1 minus x power 2 over x power 2 plus 1 to the power 4. Reduce x power 2 plus 1 with x power 2 plus 1 to the power 4. Then we get negative 2x times x power 2, negative 2x power 3. 1 times negative 2x, negative 2x. Minus 4x times 1, minus 4x. Minus 4x times x power 2 plus 4x power 3 over x power 2 plus 1 to the power 3 equal to negative 2x power 3 with 4x power 3, 2x power 3, negative 2x minus 4x, negative 6x over x power 2 plus 1 to the power 3. Set it equals 0. Cross multiplication. Then 2x power 3 minus 6x equals 0. Factorize by 2x. Then x power 2 minus 3 equals 0. Either x equals 0, either 2x equals 0, then x equals 0, or x power 2 minus 3 equals 0, then x power 2 equals 3, then x equals negative positive square root 3. Find the interval of concavity by finding the sign of the second derivative of this function, negative square root 3, 0, and square root 3. As you see, there is no value make the denominator 0 because x power 2 plus 1 never been 0. Take value less than negative square root 3, take negative 2. Find the sign of the derivative of the second derivative, negative 2 to the power 3, negative 8 times 2, negative 16, plus 12, it is negative value. Between negative square root 3 and 0, take negative 1. 2 times negative 1, power 3, negative 2, plus 6, it is positive value. Since the denominator is always positive. Between 0 and square root 3, take 1. 2 times 1, 2 minus 6, negative value. When x greater than square root 3, take 2. 2 times 8, 16. 16 minus 12, positive value. Therefore, the function here is convex, and this is the interval of concave. From negative infinity to negative square root 3, open interval, union from 0 to square root 3, this interval are interval of convex, where the function is convex, and from negative square root 3 to 0, open interval, union square root of 3 to positive infinity, the function here is concave. And x equal negative 3, substitute negative 3 in the function to find the y coordinate. Negative square root of 3, negative square root of 3 power 2, 3 plus 1, 4, negative square root of 3 over 4 is an inflection point, and 0, 0 by 0, 0, and square root 3 over 4, all these points are an inflection point. Question number 8, f prime of x equal to 1/2 cosine x over 2. Second derivative of this function f double prime of x equal to negative 1 over 4 sine x over 2, set it equals 0, then sine x over 2 equal 0. Set x over 2 equal to n pi, since the value make the sine 0 are n pi, n is any integer number, then x equal to 2n pi. Then x equal to, when n is 0, x is 0. When n is 1, x equal 2 pi. When n is 2, x equal 4 pi. This is the critical value in this interval, 0 to 2 pi closed interval. Find the second derivative, the sign of the second derivative in this at before and after these values. This is the value of x, the sign of the second derivative, and the concavity of the function. From between 0 and 2 pi, this is the second derivative function. Take pi, sine pi over 2. This is the graph of the sine. This is pi over 2. Sine pi over 2 is 1. Then the function is negative between 0 and 2 pi. Between 2 pi and 4 pi, take 5 pi over 2. 5 pi over 2, 5 pi over 4. The function is negative. Negative times negative, positive. Therefore, function is convex between 0 and 2 pi and concave between 2 pi and 4 pi. 0 to 2 pi, the function here is convex, and from 2 pi to 4 pi, the function is concave. And the point 2 pi, substitute 2 pi in the function, sine pi 0, point 2 pi 0 is an inflection point. Question number 9, f of x, rewrite this function to simplify it as 1 over cosine x cosine pi over 2 plus sine x sine pi over 2 from the rules of trigonometric function, equal to cosine pi over 2 is 0, 0 times cosine x, it is 0. Sine x, sine pi over 2, it is 1. This is pi over 2. Sine pi over 2, it is 1. Then 1 times sine over x, sine over x equal sine pi over 2 is 1. 1 times sine x equal to sine inverse x. The derivative of this function equal to negative sine negative 2x times cosine x. Equal to negative cosine x over sine square x. The second derivative of this function, f double prime of x equal to the denominator sine square x times the derivative of the numerator negative sine x times negative sine x minus the numerator negative cosine x times the derivative of the denominator 2 sine x cosine x over denominator square sine power 4x equal to factorized by sine x. From the first term we have sine square x. From the second term we have negative times negative positive 2 cosine square x over sine power 4x. Reduce sine x with sine power 4x. Then sine square x plus cosine square x plus cosine square x over sine power 3x equal to I rewrite 2 cosine square x as cosine square x plus cosine square x because I want to set 1 instead of sine square x plus cosine square x. So the derivative will be 1 plus cosine square x over sine cube x. Set it equals 0. Then cosine square x plus 1 equals 0. Then cosine square x equal negative 1. Then cosine x equal negative positive square root negative 1, not a real number. But as you see, the second derivative is undefined at the value make the sign 0. Therefore, set sine for 3x equals 0, then sine x equal 0. Then x equal to n pi, where n is integer number. In the interval 0 to 4x, x equal to, when n is 0, then x is 0. 0 is within the interval. When n is 1, then x equal pi. When n is 2, then x equal 2 pi. When n is 3, 3 pi. When n is 4, 4 pi. Those are the critical value of this function in the interval 0, 4, pi. Find the sign of the second derivative before and after this point. 0, pi, 2 pi, 3 pi, and 4 pi. Between 0, this is Uh, this is the second derivative of the function. Between 0 and pi, take pi over 2. Sine pi over 2 is 0. 1 plus 0, 1. 1 over sine pi over 2, 1. It is positive value. Between pi and 2 pi, take 3 pi over 2. Cosine 3 pi over 2 is 1. 0. 1 plus 0, 1. Sine 3 pi over 2 is negative value. So positive over negative, the function here is negative. Between 2 pi and 3 pi, take 5 pi over 2. Also the cosine is 0 and the sine is positive. Positive over positive, positive. Between 3 pi and 4 pi, the function will be negative. Therefore, the function here is concave, convex, concave, convex. And the intervals are 0 to pi, union 2 pi to 3 pi are the interval of concave, where the function is concave, and from pi to 2 pi, union 3 pi to 4 pi, the function is convex. And f of 0 equal to f of pi equal to f of 2 pi equal to f of 3 pi equal to f of 4 pi. All these values does not exist because when x is 0, cosine pi over 2 is 0, the function is undefined. When x is pi minus pi over 2, the function is undefined, and so the other values. Therefore, there is no inflection point to this function. Question number 10. F prime of x equal to the derivative of sine cosine x, derivative of cosine negative sine x. The second derivative of this function equal to negative sine x minus cosine x set it equal 0. Then sine x equal to negative cosine x. Then sine x over cosine x equal to negative 1. Then tan x equal to negative 1. Then x equal to tan inverse negative 1. Then x equal to pi over 4. You can easily find from the calculator tan inverse of 1 is pi over 4. The tan is negative and a quarter. Here the sine is positive and cosine is positive. Here the sine is positive, cosine negative. Here the sine and cosine negative. So the tan is positive. And here is negative, here is positive tan. In the fourth quarter, the sine is negative, cosine is positive, then tan is negative in quarter 2 and quarter 4. In quarter 2, x equal to pi minus pi over 4 equal to 3 pi over 4. In quarter 4, x equal to pi minus pi over 4 equal to 7 pi over 4. find the sign of the second derivative before and after these values: 3 pi over 4, 7 pi over 4. This is the second derivative of this function. Before 3 pi over 4, between 0 to 2 pi, between 0 and 3 pi over 4, take pi over 4. The value of sine pi over 4 is positive. Also, the cosine is positive, and therefore negative minus negative will be negative. Between 3 pi over 4 and 7 pi over 4, you can easily find the sign of the second derivative is positive, and between 7 pi over 4 and 2 pi, the sign will be negative. The interval of concavity R, the function is convex between 0 and 3 pi over 4, open interval, union 7 pi over 4 to 2 pi. Here the function are convex, and the function is concave between 3 pi over 4 and 7 pi over 4. Concave. And the point 3 pi over 4 and x equals 7 pi over 4 are an inflection point of this. Question number 11. F prime of x equal to 1 minus 2 sine x. F double prime of x equal to negative 2 cosine x, set it equals 0, then cosine x equals 0, then x equal to pi over 2 plus n pi, where n is integer number. In the interval 0 to x equal to, when n is 0, pi over 2. When n is 1, pi over 2 plus pi, 3 pi over 2. When n equal 2, it is greater than 2 pi. Therefore, we have two critical points. Find the sign of the second derivative before and after these two values. Pi over 2, 0, 3 pi over 2, 2 pi. This is the second derivative. Pi over 4, cosine pi over 4 is positive. Positive times negative. The second derivative here is negative. Between pi over 2 and 3 pi over 2, take pi, cosine pi is, this is the graph, cosine pi is negative 1, negative times negative, positive, and between 3 pi over 2 and 2 pi, the function will be negative. Therefore, the intervals of concavity are 0 to pi over 2, open interval, union 3 pi over 2 to 2 pi. These two intervals are the interval of convex, and from pi over 2 to 3 pi over 2, this interval is where the function is concave. And x equal pi over 2, pi over 2 is an inflection point, and 3 pi over 2 sorry, are an inflection point for this function. See you next lesson.